good morning, good afternoon, pre-calc students. Sorry for leaving you with another video of me. It's like blast from the Zoom past, and I'm sorry. But take 2 minutes. Just do problem number 1 from your do now. Go. If you're in for me, just pause the video here. I'm about to reveal the answers and allow them to work for 2, identifying and matching. Okay, now, as I identify these, which of the following functions could represent the graph to the right? Okay, here's our graph f of x. First thing that I noticed is which way the graph is going. That tells me the end behavior. Now, if they're both going down, I can look back into my notes. I know this is both even and negative, right? An even degree, right? The exponent has to be even, and a negative coefficient. So let's just go look and see if we can find our leading terms for all of these and see which of them are going to have an even degree. X squared times x, that's x to the 4th. Okay, that's a possible answer. That's even and positive. X times x, my leading term there would be x to the 3rd. Well, that's not an even degree. Oh, I can cross off A. Pardon me, this is positive, right? And we want it to be negative. So A was also not correct. C, I got negative x times s, negative x to the 3rd. I can cross that off. And D, let's see, I got 1, 2, 3, 4 there, and that's negative x to the 4th. That's a possibility. And then in E, I got x squared, x times x, that's x to the 4th, not a possibility. Well, golly gee, look at, I didn't have to do anything else but identify the leading term. And the only thing who the leading term agrees with the end behavior is answer D. Now, the other thing you can think about is the roots, right? We got a root at 0, which comes from that x squared. We have a root at 3, which came from this right here. Remember how we kind of flipped those signs? And we have a root at -3, which came from that one right there. And so really quickly identifying in number 1 that letter D is the only appropriate choice. All right, let's move on. Let's go all the way to the mad minute. The mad minute, you were just finding the zeros. You know that zeros are the roots, so we got to factor if we haven't already factored. And then we got to state the multiplicity of those roots, right? And so that multiplicity meaning like 1, 2, 3, they're really the exponent, how many of those roots there are going to be. I'm going to pause my video here. You should pause your video. And you should take 4 minutes to factor as many of those as you can and check your answers with mine. And we're back. I just revealed the answer for just 3 of these. Go check number 1, number 2, and number 5 with yours. Number 1, this was pretty simple. If you just set each one of those equal to 0, great. And then basically write down the exponent. There's your multiplicity, done and done. Number 2, you did have to factor. I factored out GCF of x first, and then I looked for factors of 25 that will add to give us -10. And that was -5 and -5. So therefore, I grouped those together and realized that that was going to be a multiplicity of 2 for that factor of 5. That x out front, that's going to be 0. There's only one of them, so there's that multiplicity of 1. Number 5, we look for a GCF of x squared. I could take an x squared out of each one of those. Now where things get a little bit crazy is that we have a difference of perfect squares here. You couldn't have just stopped right here. These are both perfect squares separated by a minus, and so we can separate those by taking the square root of the first and the second. Right? X squared times x squared is x to the 4th. Add those exponents together. And a positive times a negative gives us that -1. Those middle terms will cancel out. And so you might be thinking, we should probably stop here. But no, one of these is a difference of perfect squares. That x squared minus 1. So you'll see that that factors down a little bit more. So we have the x squared from our GCF. We have 2 difference of perfect squares. And then we've got this one just kind of random x squared plus 1 still hanging out in here. And so you can see that I found the answers to the 0, the -1, and the 1. What about the x squared plus 1? Let's set that equal to 0 over off to the side and see what happens. If we subtract 1, we get x squared equals -1. And now if we take the square root of both sides to really truly solve that, we get a negative square root of 1. Well, that's bad because we can't have negative square roots. And so this whole thing really has no solution. And so what you'll see here is that I really didn't put anything right here. There is nothing. Okay, and that's okay. So this one's only going to have 3 answers, even though it had 4 factors. And those are the 3 roots right there. Each one of those has a multiplicity. I should make sure to write that, of 1. And there's your mad minute. I'm going to clear this. So if you need that time, pause the video. Otherwise, let's move on. Let's look at the Explorer. The Explorer, I just want to look at problem number 2, the graph of this. And what we've done in the past is we've identified the roots, which is what it's going to tell you to do, right? Which is -4, 0, and 3. And then we could basically put that into factored form. And so we can actually switch those signs and we can actually write an equation here, right? The x goes out front. That's going to give us a factor of 0, x plus 4, and then x minus 3. And what they're basically saying is, if you were to actually take this function that we've just created, and you were to divide it by x plus 4, well, let's see, we got 3 things being multiplied together. If you were to divide this whole thing by x plus 4, well, essentially what's going to happen is those 2 x plus 4s are going to cancel out. You're going to be left with x times x minus 3. And what we're going to talk about today is basically how can I do this division? How can I divide basically big chunks of things or factors in order to figure out what I'd have remaining, especially if we don't have a graph like that. So let's go to our notes. We're going to do example 1 right here. Let's see. Let me get example 2 down a little bit more. Clear up some space. There we go. Example 1 in your notes. Take 2 minutes. 2 minutes. Take 1 minute. Make sure that you have example 1 written in your notes. And this is going to be titled 2.13 synthetic division. Synthetic, does that mean it's fake? I don't think so. Looks very real to me. And so when we're doing this, we're taking this whole thing and we're dividing it by this. And there's a special process for doing synthetic division where essentially, here's what we do. First, we identify all of our coefficients. And so I'm going to really quickly write our first one out front here. Notice how there's no x to the 3rd power. I'm going to go through the process and I'm going to actually add a 0x to the 3rd there so that every single exponent is covered here. So I have an x to the 4th, x to the 3rd, x squared, x to the 1st, and x to the 6th. Notice how these 3 all just came down, right? And I just added zeros in there for any exponent that was missing. So I go from 4 to 3 to 2 to 1 to no exponent. And now when we do this, why this is so necessary, because when we set up our synthetic division, you may remember this, what we're going to put on the inside of our division symbol are just those numbers, 2, 0, -6, 0, and 6. And what we're going to divide this whole thing by is whatever I have right here. Now notice this is the factor. So we're really dividing it by the root. Okay, so notice how that was x minus 1. So that x minus 1 really just tells us, right? Remember that that's x equal to 1. That's the thing that we're really going to be dividing by. Okay, so when we do this method, that's our first step. Our first step, once again, was to set it up and rewrite over there. And then we're really just going to put those coefficients down into that kind of division box. And whenever I'm dividing by, that number is going to go on the outside. Okay, let's actually do this now. Let's talk about this process. I'm going to put a little line down here, almost kind of make it a box. Now the rule is that this 2 is always going to come down to start. Whatever that first number is, drop it straight down. The second thing that you're going to do is multiply that 1 on the outside times that 2. And you're going to write that right here. 1 times 2 is 2. And then you're going to add those 2 products together to give you 2. Now I restart the process. 1 times 2 is 2. But when I add these, I get -4. Go back. 1 times -4, -8. Add those, I get -8. 1 times -8 is -8. Add those, I get -2. what we've actually done here is we've divided. The only thing that you have to remember is that this last part is actually the remainder of your division. And so when we put this all back together, we're going to go in order of our constant, x to the 0, which is just a regular number, x to the first, x squared, and x to the third. So let's put this all together. We get 2x to the third plus 2x squared minus 4x minus 8. Then we're going to put a remainder of -2, which we could also write as -2 over x minus 1, which came from the very beginning. Ooh, okay. So what you're thinking about now is just basically what just happened here. Well, we're doing some division. We were dividing some crazy bunch of junk at the very beginning by a smaller bunch of junk, right? And so if you think about this, I'm basically dividing by an x term. So I started with 4 x's, I'm taking away 1 x. So that's why it makes sense for my answer to have 3 x's as the leading term. That part does make sense. The rest of it is just a long kind of convoluted process that allows us to figure out what two things will multiply together to give us that kind of start. And so we just take that -1 and we change the sign. And we take all of these coefficients and we write them down. And then to figure out what we have remaining, we just follow that process of times 1 times whatever that beginning number is. And then we add the following. So it's this kind of process of just multiplication plus addition. Multiply, add down, multiply, add down, etc., etc., etc. And then we'll just put those answers right here are our coefficients for our final little result there. Let's go find an example problem. Let's go hunt one down. So let's kind of, for the meantime, skip example number 2. I'm going to clear these and let's go see if we can find another one. If we go down to problem set A, we see a very, very similar problem for number 3. I want you to pause the video and I want you to take 2 minutes and I want you just to kind of set up problem number 3. Now, I'm going to basically show you how I would set it up. The first thing I do again is I'm just going to rewrite this because I see that some exponents are missing, specifically the exponent of 3. So I'm going to put a coefficient of 0 there. What else am I missing? Then an exponent of 1. Everything else is accounted for. So on the inside, I'm going to have those numbers in order. On the outside, I just got to figure out what I'm dividing by. X plus 3. We're only going to include basically the root there, which is going to be -3. And that number is going to go out front. And so now it's just a reminder of what that process looks like. Okay, so I bring the -2 down. And then what do I do with that -2? I multiply it by 3. I put that right there. And then I add these two straight down. And then I begin the process times -3. Multiply straight down. Ooh, I'm going to get some big numbers here. Multiply times -3. It's going to give me a positive 42. Add down. Multiply times -3. Ooh, 42 times -3. Is that 126? And that gives me -133. Ooh. Okay, remember what this last number is. This last number is the remainder. The quotient would be our answer. And so I'm not just going to write these numbers down. Remember, these go in order for basically backwards order from smallest to greatest exponents. Remember, when we're dividing, we're really taking out an x. So the fact that I started with 4 is really telling that I'm going to be left with a leading term that is a 3rd degree. So I slap those back on there with their appropriate variables and their appropriate degrees. And there we have it. Let's go see if we can find another one. We can explain that. Let's go to number 5. Number 5 is multiple choice. This is one where I would spend 4 minutes to pause the video and allow you to work for 4 minutes on your own. Okay, I'm about to go over the answers for number 4. So hopefully you've had 4 minutes to work on it, and you are now looking at the product of your work and comparing it to mine. Now, what this is just basically saying is like, here's what we're going to put on the inside. Here's what we're going to put on the outside. It's just saying the same thing, this divided by this. Are there any exponents I'm missing? 3, 2, 1, 0. I'm not missing anything, but I'm missing a coefficient. So on the inside, I'm going to put a 1, 2, a 1 and a 6. That came from the top coefficients. And on the outside, what am I dividing by? A -2. And so before I do this, remember, we just bring down that 1. Now we multiply and we add. -2 times 0 is 0. Add, I get 1. -2 times 1 is -2. Add, I get 4. I'm always going to remember that this is my remainder. And so I got 1, 0, and 1. This is x to the 0 power, x to the first, x squared. So I got 1x squared. I got no x there, plus a 1. And my remainder is 4. Let's see if any of these have anything even remotely similar to that. I got an x squared plus 1 here. And I got a 2x squared plus 1 down here and here. I don't even need to look at that remainder. But just so you know, that 4 was 4 over whatever we started with, 4 over x plus 2. And so we can very clearly see that our answer here would be B. Focus on that process, identifying the coefficients for whatever you're dividing by. And right here, this really is your root, right? Not plus 2, but I switched the sign to be -2. Let's go find another one. Okay, great. Now I want you to go all the way down here, and you're just going to practice that exact process. And you're going to do problems 6, 7, and 8 on your own. And I would expect you to do that in 6 minutes. So pause the video for 6 minutes, allow the students to go work on those on their own. Now, once you are done, we can add one more problem to our notes. So let's go back to our notes, and I'm actually going to go all the way up here, and I'm going to add in a problem we're actually going to solve for K. Okay, now we're still going to use synthetic division. We want to find the remainder of this divided by this such that the remainder is 6. So we want to find the value of K. And I'm actually telling you what that remainder is going to be. All right, let's think about what we know. We have an x squared term, we have a k term, we have 1. So let's just put those inside. We have a 3, we have a -k, we have a 1. Those are going on the inside. And the -2, remember, we're going to switch that to be 2. Now, even though we don't know what k is, let's just go through this process and see what happens. We bring down the 3. We get, okay, a 3 there. We multiply that. We get 6. And now what we're going to do is we're going to add these together. Okay, -k plus 6. Great, I'm using the same process. Now I'm going to multiply that by 2. But if I multiply 2, 2 times -k plus 6, that gives me -2k plus 12 because I've actually got to do some distributive property. And now from here, I'm going to add those together. Well, when I add, I'm just going to add those regular constants together. And I get something like this. Now that would be kind of the whole lead in if I was doing that with just a k there. Now, they didn't ask me to do that. Well, they kind of did. But they actually said find the value of k. Okay. But it's telling me that when I divide it, that my remainder is going to be 6. And so remember which one of these is your remainder. It's the last one. So since this is my remainder, what we're going to do is we're going to set that equal to 6. We're going to subtract 13 from both sides. We get -7. And then we're going to divide by -2. And we get 7/2. Okay, bueno, it's beautiful. So with that being said, add that to your notes. Let's go to our exit ticket. Where is it? Oh, keep going. Starmani's yelling at me right now for using so much packet, not doing all the problems. Sorry, Starmani. Here's your exit ticket. What I want you to do is I want you to do all 3 of these as your exit ticket, hand it in at the end of class, and I'll see you tomorrow. Peace.